Okay, so third question is count Caesar cipher pairs. So you are given an array words of n strings. Each string has length m and contains only English letters. Okay, so two strings S and T are similar. If we apply the following operation any number of times, choose either S or T and replace every letter in the chosen string with the next letter in the across in the cyclic way. So the next letter after Z is A. Okay. Count the number of pair of IJ such that word I and word IJ are similar. So uh, like we have to make these words similar. So F should be L, same U should be A. So we can create a signature of the each word, like after how many letters U is after F. Similarly, how many letters after F this S letter is. So this way we will create a unique signature for each letter, and then we can finally uh, calculate how many words are there whose signatures are same. So let's try to solve this. First, let's calculate the length of the words and create a variable to store our answer. Now create a signature function. So let's create a signature function which will take word as the input. And what will be the base for it? Always the base will be the first character of the word. So base will be word of word, the first character. And simply we can return the tuple here. Return tuple because we can means store that in a dictionary, that's why. So we can simply store tuple here. We will calculate ord of c minus the ord of the first letter, which is nothing but the base, and then total number of alphabet. So simply do modulus 26 and for c in word. So we can simply return this. Now try to create the frequency dictionary to create the to store how many words have the same signature. So simply default dict when c is equal to default dict. We have not imported default dict. Let's do that. So from collections import default dict. We have stored the file. Now simply go through the words array for word in words. The sign will be simply call the signature function here. Signature of that particular word and increment the value. So frequency of that sign plus is equal to 1. So now we have got how many have the same signatures. So to now we have to take out the total number of combinations we can make. So you remember the formula of NCR total number of how we calculate the total number of combinations, that's NCR, and here NCR is nothing but NC2. So the formula is n minus r factorial into n minus r factorial plus n factorial into n minus r factorial into r factorial. So we all know this formula. You can simply divide it. You miss the division here. N factorial divided by n minus r factorial into r factorial. Uh, this is the r factorial sign. Yeah. So this will simply comes into like n can be written as n into n minus 1 into n minus 2 so on factorial, then divided by here r is nothing but the 2, so n minus 2 n minus 2 factorial n minus 2 factorial into 2 factorial, which will nothing will be which will come n minus 2 factorial will cancel themselves, so it will be simply n into n minus 1 and 2 factorial is nothing but 2. So this will be the final formula to calculate the total number of combinations. So now simply go through the values of the dictionary. So for count in frequency dot values if count is greater than 1 means they have the same signatures. So we can simply add in the answer, and what is the formula to total number of combination we just generated n into n minus 1 by 2. Here n is nothing but the count, so count minus 1 and simply divide it by 2. So and we can return the answer. This should work. Let's try to run our test cases. Okay, so we have missed some bracket, I think. Count to count minus 1. Is this the extra one? I think we have given two brackets here. Let's try to run it again. Yeah, so test cases have been passed. Let's try to submit this. Yeah, so code has been submitted successfully. Thank you.